Okay, so what you see here on this graph is I have drawn a curve in red, and I've drawn two lines going through the curve. I've drawn a tangent line to the curve. A tangent line is a line that touches a curve in exactly one point. Takes you back to geometry and thinking about circles. A secant line is a line that goes through a curve in 2 points. Okay? Calculus is all about rates of change. You know what a rate of change is, at least of a line. It's the slope, how it changes in y over x. So back in college algebra, you also talked about average rates of change for one brief, really quick lesson. And they gave you some curves, and they said, well, what's the average rate of change of the curve? But you picked 2 points, and you calculated the slope. So if I want to discuss how my curve is changing, I might say, well, the slope of my secant line would be an average rate of change of the curve, and it would be a y2 minus y1 over x2 minus x1. So let's get the points off of our graph here. I've done this very generically. I'm saying my first point, my x1 here, is just x. And my second x value is another point h away from my first one. Then my y1 is just the function evaluated at x. And my y2 is the function evaluated at x plus h. So if I plug that into my slope formula, I'm going to get f of x plus h minus f of x over x plus h is my x2 minus x is my x1. And x minus x goes to 0. And we get f of x plus h minus f of x over h. Okay, so this is just a different way of writing the average rate of change of a curve. It's a generic way of writing it for slope. However, if I want to know how my curve is changing at this point x, it really would be the slope of the tangent line, right? But I only know 1 point at the tangent line, so I can't plug into that formula. Let's draw another secant line, and I'm going to back my second point. Whoops, I hate it when it does that. Oh, come on. This video is already recorded, by the way. I had to do it in the spring, and it took me like 10 tries to do it without getting that grid to move around in the back while I was drawing. So that's probably the video I'll post for you. Okay, so I have a new secant line here, but it's a secant line because it goes through in 2 points. But I've changed my h to be smaller than it was before, right? Now look at my secant line, my new one in yellow, compared to the green one. The one in yellow has a slope much closer to my blue tangent line, right? So if we want to figure out the slope of the tangent line, we want to make our second point get closer and closer and closer to our original x, which means what is happening to h? It's getting smaller and smaller and smaller. So since I can't, at the tangent line, find a second point to put into the slope formula, what we can do is take the limit of this as h goes to 0. And that's going to give us the slope of our tangent line. So what that formula there is saying, if I want the slope of the tangent line, I want to back my second point down to where it's at that same place. And the slope of a secant line, I said, is an average rate of change. Well, when it's at a single point, we call it an instantaneous rate of change. Okay, so everything I just did is to give you the idea that we are finding a slope of a curve at a point on the curve. So if I'm describing how my curve is changing, discussing the slope of the tangent line helps me understand that, right? If my tangent line has a positive slope, I see that my curve is increasing at that point. If it had a negative slope, that would mean my curve is decreasing at that point. So it's a way to describe what's happening to the curve. Okay, so this is the definition of a derivative. A derivative describes how a curve is changing. If it's in terms of x, it describes the entire curve. If we pick a point and plug it in, then it gives us the slope of the tangent line at that specific point. The notation for a derivative is f prime of x. Okay, that's not raised to a first power, that's just a prime. That's the symbol we use for derivative. And when I say to you derivative, I want you to say back to me it means slope. If I ask you how to find the slope, you tell me take a derivative. And this is the formula for it. There's also some other notations. If I gave you, instead of f of x equals something, if I give you y equals something, then you can write the derivative as y prime. And then, just like limit as h goes to 0 is a command saying do direct substitution, we have a command for take the derivative. Over here, this means take the derivative of this function f of x. Oops, I'm spelling it wrong. And the result of that would be dy dx. Okay, so when the d dx is separate, it's a command saying take the derivative with respect to the variable x, and the result of that would be dy dx. So all three of these are notations that you'll see me use for derivative, the result of taking a derivative.
So it's supposed to be d over dx.
This one, the result is dy dx. It means I took the derivative of y with respect to x. This d dx over here means take the derivative of what comes after with respect to x. Now, in calculus 1 and 2, it's always with respect to x. Well, there's one little caveat to that comes later. But in Calc 3, we start doing multivariable calculus, and we might take derivatives with respect to y or with respect to z, and so knowing that it's with respect to x is important. For you guys, it's always going to be a d dx. Or if I write an equation, it's always going to be a single variable. So what you're taking right now is called single variable calculus, and then Calc 3 is multivariable. Okay, so we're going to use the formula for the limit definition of a derivative to find the slope of the tangent line to f of x equals 2x minus 3 at a specific point. Now I want you to think about this for a minute. F of x equals 2x minus 3, that's a line. What's the slope of that line?
2.
So we better get 2 for an answer, right? Because it's not curvy, so the tangent line to that is going to pretty much lay on top of it, right? But we're going to use the formal definition, which is that the derivative is the limit as h goes to 0 of f of x plus h minus f of x over h. And notice, in direct substitution, this would make us divide by 0. So that's where all the tricks we learned about manipulating limits are going to come into this. Because I'm not going to give you a problem where it ends up being the answer's infinity. So those h's are going to have to cancel out in some way. So the first step is to find f of x plus h. So that means we're going to, in our original equation, replace the x with an x plus h. So when I do that, if I distribute the 2, I'm going to get 2x plus 2h minus 3. And then before I take the limit, this part of the formula is actually called a difference quotient. Difference means subtraction, quotient means division. So since it has both going on, it's called a difference quotient. You may have heard that vocabulary in college algebra. My difference quotient is 2x plus 2h minus 3, which is what we just found for f of x plus h, minus the original f of x. Make sure you use parentheses because we want to distribute that minus to both terms in the f of x, all over h. So if I distribute this minus here, I'm going to get 2x plus 2h minus 3 minus 2x plus 3 all over h. And now I see that 2x minus 2x goes to 0. Negative 3 plus 3 goes to 0. So we have 2h over h, which is just 2. So when these are done correctly, that h in the denominator is always going to simplify out. And now to find the derivative, I still have not found it yet because I haven't taken a limit. The derivative is the limit as h approaches 0 of 2, which is 2. And it doesn't matter that I said to find the slope at that point 2, 1, because that's the slope anywhere because our original function was a line, correct? So for any point, I could have said that would be the slope of the tangent line. Okay, now that was a really easy one so you could get the steps down. These are going to get quite a bit more complicated. We want to find the derivative for f of x equals x squared plus 1. So now I've got a curve, right? I got a parabola that opens up. And I didn't ask you to find the slope of the tangent line at a point. I just want the derivative anywhere. So our answer is going to be in terms of x. So first I want to find f of x plus h. So I replace my x with an x plus h. And let's rewrite that so I can see that I need to multiply this out. That's x plus h times x plus h. And I rewrote it because a lot of times I see people say, oh, that's just x squared plus h squared. It's not. If we actually FOIL it out, it's going to have some middle terms. So when I multiply this out, for the first, I get x squared. For the outer, I get x times h. And for the inner, I get another x times h. So that's 2 xh's. And for the last, I get an h squared. And then we still have this plus 1 here. Okay, so then let's find our difference quotient, which is the formula for the derivative before we take the limit. So I've got this x squared plus 2xh plus h squared plus 1, and we're going to subtract the original function and put it all over h. So if I distribute this negative, we'll get x squared plus 2xh plus h squared plus 1 minus x squared minus 1. The mistake that I'll see people make is once you get the hang of this and you realize all this stuff is supposed to go to 0 if it doesn't have an h in the term, you won't distribute that negative and you'll put 1 plus 1 and tell me it's 0, and that would not be true, correct? So make sure you distribute that negative. So this is all over h, and then I see x squared minus x squared goes to 0, plus 1 minus 1 goes to 0, and notice the terms that are left in my numerator have an h in them, which I can factor out and cancel with my denominator. When this is done correctly, that's always going to happen. So that goes to 1, and my derivative now is the limit as h goes to 0 of 2x plus h. So this time, I have a direct substitution to do. We put that 0 in for the h, and the answer is 2x. So 2x describes how the slope of my parabola is changing. Now think about this. With a parabola, and it's centered at 0 and it's shifted up 1 for this graph, right? Well, if I'm on this side of the parabola and I draw tangent lines on the left-hand side, it's decreasing, and those tangent lines would have a negative slope, right? Well, so if I were plugging in negative x values into this derivative, we'd get negative slope. And then on the right-hand side of my parabola, it would switch to positive values. So it makes sense, right? Okay, so we are going to have to multiply out the x plus h 3 times here. And that gives me x cubed plus 3x squared h plus 3x h squared plus h cubed. And then my f of x plus h is all of that, plus we still have to plug it into the 2x, right? So it's x cubed plus 3x squared h plus 3x h squared plus h cubed plus 2 times x plus h. And we'll distribute that 2. All right, so all I did there was find f of x plus h. Now we'll plug it into the difference quotient. So basically the derivative before I take the limit. And I get all of that. Minus the original function, which is up here. All over h. So we're going to distribute that negative. And I get x cubed plus 3x squared h plus 3x h squared plus h cubed plus 2x plus 2h minus x cubed minus 2x all over h. And if we've done it properly, once we clean this up, every term should have an h in it to be able to factor out and cancel with denominator. So I see x cubed minus x cubed. I see 2x minus 2x, and everything else has an h in it. Okay? I'm a step ahead of myself. That is that. Okay, I'm right here.
The 3x squared plus 3xh plus h squared plus 2.
Plus 2h, right?
Mm-hmm.
Or did you already take an h out in what you said?
Yeah, I already divided by h. So.
Okay, I didn't. So I've got 3x squared h plus 3x h squared plus h cubed plus 2h over h. So I was just rewriting the last step for myself because it's on the new slide. Factor out the h, and I get 3x squared plus 3xh plus h squared plus 2. And our h over h goes to 1. So we have 3x squared plus 3xh plus h squared plus 2. And now to find the derivative, we take the limit.
Wait, can't we just crunch all that and put x plus h to the power of 2 and then put a 3 on the outside of it?
Is it your phone? Is it this phone? Oh, somebody left their phone in here. It's their phone. It's their alarm clock. I noticed the phone when I came in, but I figured it didn't belong to any of you guys because we haven't been here in a week. Okay. I'm not sure what you're saying. Can you factor a 3 out of here and here? Is that what you're asking?
No, I changed my mind. I take it back.
Okay. All right, so until I take a limit as h goes to 0, I haven't found the derivative. At this point, you might be able to look at it and tell me what the answer is going to be, right? Because the h terms are going to go to 0. But you must show me the step of taking a limit. Otherwise, all you found is a difference quotient and then like written down an answer. And there's my answer. And 2 weeks from now, you're going to be able to just look at the original problem and tell me what that answer is. Okay? Now, I know it's long. I know it's tedious. I also know the importance of understanding where a derivative comes from and that it's slope in calculus. But on your test, the majority of your test is going to be everything we've done up until today. And then there will be maybe 2 derivative problems and a find a tangent line problem at most. And we're going to do a find a tangent line problem in a minute. So the majority of your test will not take this much time and space. Okay, so some of our old tricks are going to come into finding these. This one, f of x plus h is really easy, right? We're just going to put an x plus h under the radical. So I can go straight to my difference quotient here. There's not a whole lot I have to do to figure this out. And my difference quotient is the square root of x plus h minus the original function all over h. Now, if I were to take that limit, we'd be dividing by 0, right? And we know that I need to cancel that out. And so when we see square roots, what's our method? Multiply by the conjugate, right? So I'm going to multiply this by the square root of x plus h plus the square root of x over the square root of x plus h plus the square root of x. So in the numerator then, we're essentially foiling that out, and it's a difference of squares. It'll get rid of the square root terms. And so I get square root of x plus h times square root of x plus h is just x plus h. On the outside, I get square root of x times square root of x plus h, but then that cancels with the inside minus square root of x. So those middle terms go away, and the last is going to give me negative x. And in the denominator, we just leave it be because we want that h to end up simplifying out. Well, it will because x minus x goes to 0, right? And now I have h over h times what's in the parentheses. And that will go to 1. So my derivative then is the limit as h goes to 0 of 1 over the square root of x plus h plus the square root of x. So we're plugging in a 0 for that h. So I'm going to get 1 over, well, I got the square root of x plus square root of x is 2 times the square root of x.
On the test, do you want that simplified? Even more?
You mean rationalized?
Yeah.
No.
Okay.
No. We harp on rationalizing so much in pre-calculus, and then you get to calculus and we're like, it's fine, leave it. especially when it's in terms of a variable. But even when you get to Calc 3, which you'll find, even if that was like 1 over the square root of 2, we'd leave it that way. Yep.
Were you supposed to write dy over dx, or does it matter?
I can, but I used this notation. It's equivalent.
Okay.
That is one thing I'm not going to nitpick you to death on the test. But yes, technically I asked for dy dx, so it should be dy dx equals 1 over 2 times the square root of x. So it's a good catch, because I wasn't consistent. But those 3 notations that I showed you earlier are interchangeable. And you'll see me do it frequently. Okay, now, I'm really trying to get you to know derivative means slope. So on every test you take, I will put a tangent line problem on it, because that's where you actually have to find the slope and not just the derivative, right? What we just found on the last couple examples was a derivative that had an x in it. It wasn't a number. Slope of a line, of a tangent line, is just a number, right? And it tells us something about the line. If it equals 0, it's a horizontal line. If it's undefined, it's a vertical line. If it has a positive slope, we know it's increasing. Negative slope, we know it's decreasing. So if I ask you to find the equation of a tangent line, then what we're going to use is the equation of a line in point slope form to get to that. So what I need in order to write an equation of a line is a point and a slope. Well, I gave you the point. It's over here. Here's my x1, y1. And slope is, say it for me, say it for me.
Derivative.
It's derivative. So to find the slope, we have to take the derivative of this. So the f of x plus h is pretty easy. It's just 2 over x plus h. Then my difference quotient is 2 over x plus h minus 2 over x all over h. And we started off class with one of these from the old homework, right? When we see fractions, we think, got to get rid of the denominators. We need to know what the common denominator would be. So if I were trying to combine these two fractions, what would I use for a common denominator?
X plus h.
X times x plus h is what that common denominator would be, right? I'd multiply the first fraction by x over x, the second one by x plus h over x plus h. But instead of finding a common denominator in a compound fraction, we'll just multiply the top and the bottom by that and get those inner denominators to go away. So when I do this, when I multiply this first term here by x times x plus h, the x plus h's cancel, and I'm left with 2x. When I multiply the second term, 2 over x, by x times x plus h, those x's cancel, and I'm going to have minus 2 times x plus h all over h times x plus h. And we'll distribute this negative 2 here, and I get 2x minus 2x minus 2h over h times x plus h. And 2x minus 2x will go to 0. And now I have negative 2h over h. So what happens there?
Becomes -2.
It becomes -2. So the derivative is the limit as h goes to 0 of -2 over x times x plus h, which would just be -2 over x squared after we substitute the 0 in for the h. Okay, so I found, yeah.
Can you go back to the last one?
Good. Okay, so we found the derivative. If we're going to write the equation of a line, let me rewrite it here. We've got x1, y1. We need m, and m is our derivative evaluated at this x value, right? Because that's where we want to draw the tangent line to this curve. So I'll evaluate my derivative at 1, which would be -2 over 1 squared is just -2. And now I plug these values into this equation here. So I get y minus 2 equals -2 times x minus 1. And that's a perfectly good answer, but WebAssign tends not to ask you in point slope form. On the test, I strongly suggest you stop there if I don't specify, and I usually don't. Because at this point, I've done all the calculus. I have a perfectly valid equation of a line. If you keep going and you make a mistake, I'm going to count off. Now in WebAssign, you'll tend to notice it gives you y equals and then a box for the answer. So you have to solve for y. So I have to distribute the -2, and I get y minus 2 is -2x plus 2. Then add this 2 to both sides, and my answer becomes y equals -2x plus 4.